Hi, good morning. This video may be the last video for combinatorics. That is why all the important fundamental phenomena I have discussed in this video. Please follow carefully. In this, I have discussed about the similar, alike, identical objects or balls or things or gifts or rewards, awards of alike. So how to distribute? How many ways we can distribute? This is quite different from five people are there. We have to select 3 people out of 5 people. For our servants in our house, we want 3 servants. There are 5 servants came to us. We have to select 3 servants out of the 5 servants. So that is 5C3. 5C3. Because 5 servants are different. And 3 servants we want. 5 servants are not alike. They are different. Okay. So this is one case. Very common general case. The different case is 5 red color balls are there of same size. You have to select any number of balls, 1 or more. 1 or more. 1 ball you can select. Another 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 ball you can select. Okay. In this, you have to learn one new thing. Here, no selection is also there. I don't select any ball. I select 5 balls. 1 ball, another ball, another ball, another ball, another ball I will select. So 5 plus 1. 5 plus 1 means what is 1? 1 is no selection. I don't select any ball out of 5. That is one way of selection. No selection is one way. So 5 plus 1. Like that 4 green, 4 plus 1. 5 plus 1 into 4 plus 1 balls. Out of it, I have to subtract 1. Why 1? Because no selection is there. No, that no selection is one way only. That is why I am subtracting minus 1. 5 plus 1 into 4 plus 1 minus 1. Like this, I will select 1 or more balls of identical balls of 5 red and 4 green balls. About this I explained it in my notes. I explained it very carefully, slowly explained, very steadily explained. Try to understand it. And another formula is there from combinatorics. NCR minus 1 plus NCR equals to N plus 1 CR. NCR minus 1 plus NCR equals to N plus 1 CR. Okay, this application of this formula, this is also very important, because in many cases we apply in the solutions of some cases. And moreover, here similar balls, similar persons, round table, in the round table conference, and for the dinner around some people be seated. So 10 people are seated around. In how many ways we can arrange? We can arrange how many ways? 10 people, how many ways we can arrange 10 people around the table? Either for conference or for dinner, like that. So 9 factorial, 10 minus 1 factorial. You have to take that one, 10 minus 1 factorial. When 10 minus 1 factorial by 2, when there is garlands, necklace, chains, with beads, if we string and we will get one garland like that, then we will write with 10 flowers, we will say with 10 flowers, with 10 rose flowers, one garland means 9 factorial by 2. For the persons, only 9 factorial. 10 people are there who are seated round the table, is nothing but 10 minus 1 factorial. That 10 minus 1, 9 factorial, the ways of arrangement of these 10 people. That also we discussed. Just what I remembered, I discussed with you now. But in the notes, many things, we have discussed many things in the notes. Here, at the same time, this may be the last class for combinatorics. All JEE main previous questions and some tough questions from AIEEE. In olden days, AIEEE questions are very tough and they are the best questions. Those questions also I discussed. What I discussed and what I explained, please listen carefully, and if necessary, go through my notes and listen to my explanation 3 watches. You will learn more. Okay. At the same time, many times I used to tell you to share, subscribe, to click the bell icon. If you have any kind of doubts and clarifications, you can use the comment box. Comment box will be there. Comment box or comment region is there nearby my video. You can give your comments, or you can explain your clarifications or doubts, anything in the comment box. Okay, these things. Or otherwise, if you want to chat in Messenger, you can chat in the Messenger. Okay, with the help of Messenger, we can chat. However, if you are very closer to me, you will learn many more things. If that is up to your interest. At the same time, to get more update videos, you have to share and subscribe. It is very, very important. And moreover, from the next video onwards, I am going to start definite integrals. I am going to start from calculus section, definite integrals. It is playing important role in JEE, in joint entrance examinations, in common entrance examinations, in the national level. All national level exams will give more importance to different integrals. I will discuss from the next video onwards the different integrals. Please listen carefully, learn the subject. I am not asking any fees, no, from you. You have to maintain some data in your touch phone and you go through my classes. Freely listen, freely learn. Mostly this is I meant for the poor people. Once I told, many times I told. Tell the poor students who are studying in government colleges. Okay, some are poor in government colleges, but they are intelligent. Brilliant students are also there. More aspirants are there in government colleges. Please tell your friends, such friends, if there are, please tell them. Please pass on this news. Okay, this is a good service from your side to your friends. It is very important. Okay, for the poor people, please do service. Pass on this news to the poor students who are studying in government colleges or not studying, doing some other jobs, but they are not able to go to college. Even to such people also, please convey this message. It is my sincere request. Mostly for them only I am doing. If they visit, if they watch these videos, and I will be more happy. Try to convey this to all your student world. Okay, so thank you very much. Please carefully listen to the explanation and go through my notes and listen carefully my words. Please follow it, because up to 2021 I am and I will be doing these type of things, making all these videos up to the syllabus be completed. So listen carefully. Thank you. My dear students, this video may be the last video for combinatorics. In this video, you are going to learn the different various questions with different phenomena. Follow carefully. First I am going to explain in a nutshell fundamentals. In a nutshell, fundamental means the brief way of explanation about fundamentals. Not each and every small thing, but very important fundamentals which are necessary and useful for JEE. If 5 alike pens, 6 alike pencils, 7 alike erasers are there, it is a simple question. Day-to-day life, it happens to be that same color balls, same color chocolates, or same tasted chocolates, 5 alike pens, 6 alike pencils, 7 alike erasers, then number of ways of selecting any number of things out of them. This is fundamental important phenomena. Number of ways of selecting any number of things out of them. Any number of things means I have given within brackets one or more. One or more. One thing or more things. Any number of things. Okay. How to select? For this, I have given the ready-made answer. The ready-made answer given. But you did not understand why you have kept 5 plus 1, 6 plus 1, 7 plus 1, minus 1. Why can we keep like this? We have to know. I will explain like this. 5 elect pens are there. Asking any number of things out of them. So, out of 5 elect pens, I don't select any pen. So, no selection, also one selection. No selection, also one selection. Therefore, out of 5 elect pens, there is a chance on my part. I don't like to take any pen. That is called no selection. That is, no selection is one way. And next, one pen I may take, or else 2 pens I may take, 1 pen 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 I may take. No pen I take, no pen I may take, 1 pen I may take, 2 pens, second pen I may take, third pen I may take, like that. So may take. Once I told, it is or else, like that. Because the question is any number of things, any number. 1 you can take, 1 pen you can take, or no pen you can take, any number. Or 4 pens you can take, like that. No. So here 5 plus 1. What is 5? Any pen. 1 pen. You keep number there. Or another pen, or another pen, or another pen, or another pen. 1 plus 1 plus 1 plus 1 plus 1. That is like that 5. Plus 1 what? No pen I select. 5 plus 1. Similarly, 6 plus 1, 7 plus 1. Up to this, okay. What is this minus 1? Because the question is any number of things out of them, no. So, no selection is there, no, in this, no selection. How many ways? One way only. How many ways for no selection? One way only. How many ways for no selection? One way only. So minus 1. If I subtract to 1 from 5 plus 1 into 6 plus 1 into 7 plus 1, definitely I will get any number of things out of them. Or within brackets I told no, 1 or more. Because in this question 1 or more, No selection is not there. That is why no selection is one way, so minus 1. That is 335. This is very important. On the basis of this phenomenon, positive divisors of 1080. Positive divisors of 1080. First of all, I have to write 1080 in prime numbers. Only in prime number multiples. 2, 3, 5, not 6, 7, not 8, not 9, not 10, 11. These are the prime numbers. In the multiples of prime numbers only you have to write. If you write like this, taking 2 and 3 and 5, then it ends. It gives us 1080 by some exponents, that is by some indices. What are the indices? 2 cube, 3 cube, 5 power 1 powers, indices. There ends and gives us 1080. The number of positive divisors is, the formula is, you take these indices, 3 plus 1, 3 plus 1, 1 plus 1. Same formula. But not minus 1. That is 32. So there are 32 positive divisors of 1080. There are 32 positive divisors of 1080. That is the meaning of this. By using this phenomena, we can follow to give answer for this. You see, on the same phenomenon fundamental, this is original phenomenon. From this, we are establishing all these things. Divisors we have established, and we are going to establish this one also. What is this? Let us see. To pass an examination, a student has to pass in each of the 3 papers. Each of the 3 papers. In how many ways can a student fail in the examination? To pass an examination, has to pass in each of the 3 papers. How many ways can a student fail in the examination? For each of 3 papers, there are 2 choices, P or F. What is P? Pass or fail. There are 1, 2, pass or fail, 2 choices, 2 cube, because has to pass in each of the 3 papers. Has to pass in each of the 3 papers. For each of the 3 papers, there are 2 choices, pass or fail. There are 2 cube, 8 choices. But a student passes only if passes in all papers. The ways to fail. The ways to fail. To pass one way only. There are 8 choices. But a student passes only if passes in all papers. How many ways? One way. One way only you can pass the examination. Because to pass an examination, a student has to pass in each of the 3 papers. Pass in each of the 3 papers. So every paper he has to pass. How many ways? One way only he has to pass. But how many choices are there? 2 cube equal to 8 choices are there. One way is there. That is 1 to pass the examination. If you subtract, you will get 2 cube minus 1 is the ways to fail. You see, under the same phenomena, the various distinct questions have been framed. Please observe this. To understand better, watch 2, 3, 4 times this video. Still more fundamental phenomena. The number of ways of distributing 10 identical balls in 4 distinct boxes. Same phenomena. First I discussed the phenomena, no? That one only. Such that no box is empty. But the first phenomenon we discussed, no, before this, that is different from this. This is not similar to that. Here, small logic is there. The number of ways of distributing 10 identical balls in 4 distinct boxes. You see, 4 distinct boxes. In 4 distinct boxes, the number of ways of distributing 10 identical balls. All are identical balls. Same, alike pens, alike. First phenomena, in that identical, only the identical or alike. This phrase only is similar, but the phenomenon is different. 4 distinct boxes are there. These are 4 distinct boxes. 10 identical balls are there. Such that no box is empty. All boxes should be filled up. How to do? So, first of all identical balls, no. All are red balls. All are red, same size balls. Size is same, color is red. All are balls, 10 identical balls. 1 red ball, you please keep here and fill up in the first box. 1 red ball, please fill up in the first box, because so that no box is empty. First you fill up. This is the logic, that's all. So that no box is empty, the logic is, first you fill up with 1 ball. How many balls will be left? Out of 10 balls. Out of 10 identical balls, how many balls left? 9 identical balls. How many boxes left? Out of 4 boxes, they are different boxes. They are not similar. They are different boxes. Out of 4 different boxes, 3 boxes left. So, automatically this one, 9C3, we can fill up. We can fill up 3 boxes out of 9 identical balls. This is the only logic. If you do like this phenomenon says that number of ways of distributing 10 identical balls in 4 distinct boxes such that no box is empty. Similar way, I have given one formula, n minus 1 CR minus 1. The number of ways of distributing n identical objects among R persons such that each person gets at least one object is. Same phenomena. Same phenomena. This one, same phenomena. 5th one I ticked. What is the formula? N minus 1 CR minus 1. What is it? 9C3 n minus 1 CR minus 1. It means how it has come. What is the idea of it? First you fill up the first box in any identical ball, and then automatically if you write 9C3, that will tell you, 9C3 will tell you the number of ways of distributing 10 identical balls in 4 distinct boxes such that no box is empty. Such that no box is empty. Similarly, such that each person gets at least one object. So there are n prizes are there. N prizes. All prizes are identical naturally. Same type of prizes are there. You have to distribute some students on the stage, or students on the stage, such that each person gets at least one object. So, like this, one prize or one award should be given at least to one student, at least one award, at least one award or one gift each person must get. Like that, if you take this condition and then the same phenomenon minus 1 CR minus 1. Please observe this. Whereas, don't confuse yourself. The number of ways of choosing any 3 places from 9 different places. This is 9 different places. Any 3 places. This is 9C3. The number of ways of choosing any 3 places from 9 different places is 9C3. This is quite different phenomena. This is direct selection phenomena. Whereas this 4th one and the 5th one are different phenomena. Identical, similar, identical objects, alike objects, alike prizes, awards, at least one person, one award, at least one award, each person gets. Like that. Or no box is empty. Both are same meaning. No box is empty. Or at least one award one must get. Both are same meaning. Like that. Next you see, I want to explain this very fundamental the number of ways in which 6 men and 5 women can dine at a round table. In the case of round table, we have to keep the persons once this phenomena I discussed once. I am remembering you. If you are very update of my videos, you can easily understand and you can remember. Previously I discussed about this. If it is a garland or necklace, for that n factorial by 2. For the persons who sit round table, no by 2. That is n minus 1 for garland, n minus 1 factorial by 2. For chain, for garland or for necklace, n minus 1 factorial into 1 by 2. But for the persons who sit in the round table, for this no by 2, no multiplication by 1 by 2. Only n minus 1 factorial. Suppose 7 persons sit on a line, arrange them 7 factorial, that's all. Same 7 persons sit around the table, arrange them 6 factorial. Please remember this. Again I am telling, 7 people in a row, in a line row, ought to be seated. How many ways we can arrange? 7 factorial ways. Same 7 people, if we make them around the table for the dinner or for meeting, for conference, and then not 7 factorial, that is 7 minus 1 factorial, 6 factorial. This is a new phenomena. By 2 will be coming only in the case of garlands and chains, necklace, for the beads, for the objects, for the things of which we make a round shaped one, then only it will be by 2. But in case of persons, no by 2. By 2 never comes. Only n minus 1 factorial. Now the question is the number of ways in which 6 men and 5 women can dine at a round table. Total 11 people, they will sit for the dining, sit around the dining table for the dinner. Here one condition is there. If no 2 women are sit together, if no 2 women are to sit together, no 2 women are to sit together means 2 women, they won't like to sit because they are always talking, chatting, chit-chatting, extremely chit-chatting and coming to the quarrel, and they will be falling in the disputes. by extra chit-chatting. That is why two men we are not going to keep side by side. Here the condition is if no two women are to sit together. For that, the problem with women, therefore, we don't touch women, we keep the women away, aside for a while. And we are taking up only men, 6 men, and we are making 6 men around the table. How many ways? 6 minus 1 factorial, 5 factorial ways. 6 men, observe. 1, 2, 3, 4, 5, 6 men. 6 men, how many ways? 6 minus 1, 5 factorial ways. How many gaps are there? 1, 2, 3, 4, 5, 6. 6 gaps are there. So, in these 6 gaps, we can make the women sit. Then, 2 women, middle 1 man. 2 women, middle 1 man. 2 women, middle 1 man. 2 women, middle 1 man will be coming. Then, according to the condition that 2 women should not sit, that condition will follow, no. That will follow, no, that condition. Women condition will follow, no. Women problem will be no more, no. That is why 1, 2, 3, 4, 5, 6. 6 choices are there. Out of these 6 choices, we can arrange. Arrange means P. P means permutations. P means permutations. We will arrange 6 people. Okay. How many childs are there? 6 childs are there. How many? 6 childs. 1, 2, 3, 4, 5, 6 childs are there. That is this 6. How many women are there? 5 women are there. 6 P5. So in the 6th choice, between man and man, 6 childs are there. 1, 2, 3, 4, 5, 6 childs are there. In either of 6 childs, 5 women we can keep seated. This is 6P5. So 5 factorial into 6P5 is the answer. 5 factorial into, what is 6P5? 6P5, do you know 6P5? No, you don't know. 6P5. 6P5 is here 6, 5, 4, 3, 2, 1. That's all. Here 5 is there, no. 5 times you write backwards to the natural numbers. 6P5. If 6C5 is there, like this you write whole by 5 factorial also you will write. When there is C, 6C5, when there is 6C5, like this you write whole by 5 factorial also you will write. Because this is permutations P, 6P5, that is why by we don't write anything. Only for P permutations we will write backwards natural numbers. Here 5, no, 5 times we have to write. 1, 2, 3, 4, 5 times we will write. Up to this. What is this? 6 factorial. What is this? 6 factorial. That is 6 factorial. 5 factorial into 6 factorial is the answer. 5 factorial into 6 factorial is the answer. How it has come? I have told you like this. Now, this fundamental phenomena over. Now we are going to discuss different questions in the previous exams of JEE or JEE. The range of the function f of x equals to 7 minus x px minus 3 is. Answer is 1, 2, 3. Range. So what is the relation between 7 minus x and x minus 3? How it should be? N, P, R, how N and R should be? N should be greater than 0, greater than or equal to 0. R should be greater than or equal to 0. Above all, N greater than or equal to R. This for NPR. So here 7 minus x greater than or equal to 0, x minus 3 greater than or equal to 0, 7 minus x greater than or equal to x minus 3. So you can write like this. What you get? X less than or equal to 7, x greater than or equal to 3, x less than or equal to 5. These are simplified like this from the first step. And then, what is the domain of the function? Our question is range of the function. If you want to find range, you must know first domain. Domain you must know first. At first you must know it. What is the domain? Greater than 3, 3. 4. X less than or equal to 5. X equal to 5 you can take. Below it also you can take. X less than or equal to 7. So below 7 also you can take. 7 also you can take. 7 also you can take means 7 means 7 0. Below 7 means 6 if you take 1 P3. So it is against the rule, no. What is the rule? N greater than or equal to 0, R greater than or equal to 0, above all, N greater than or equal to R. N should be always greater or equal to R. So, according to this condition, domain must be 3, 4, 5 only. You observe. 3. 4 P0. Okay. 4 greater than 0. 4. 3 P1. Okay. 3 greater than 1. 5. 7 minus 5. 2 P2. 2, 2. Both are same. No problem. 3, 4, 5. If you take 6, 7 minus 6, 1. 3. 1 P3. 1 should be greater. 1 P3 is wrong. 7 if you take, 7 minus 7, 0. 0p4, wrong. Because according to our definition, it should follow. So domain is 3, 4, 5. And now we can find range. What is f of 3? What is f of 4? What is f of 5? We'll find. What is f of 3? F of 3. 4p0. 4p0. How much? 1. F4. 3p1. 3. F5. 2p2. 2. So 1, 2, 3 in order. The range of the function is set of 1, 2, 3. At an election, a voter may vote for any number of candidates, not greater than the number to be elected. At an election, a voter may vote for any number of candidates. Any number of candidates he can vote. A voter may vote for any number of candidates, not greater than the number to be elected. There are 10 candidates and 4 are to be elected. 4 are to be elected. 10 candidates are there, 4 are to be elected. Out of 10, 4 people only should be elected. If a voter votes for at least one candidate, if a voter votes for at least one candidate, then the number of ways in which he can vote. You see, one voter, at least one candidate he has to vote. How many people? 10 people are there. Out of 10 people, one person he can vote. Because at least one person he has to vote. Or else means plus, or else 2 people the same voter can select. Means can vote out of 10. Or else same voter 3 people he can vote. Or else same voter 4 people he can vote out of 10. Up to 4 only, because 4 only to be selected. That is why in the question it is given, at an election a voter may vote for any number of candidates not greater than the number to be elected. Not greater than the number to be elected. 4 people only to be elected. That is why a voter can vote one person, because at least one person he should vote, or else 2 persons he can vote, or else 3 persons he can vote, or else 4 persons he can vote. That is the maximum number 4 only, because 4 to be selected, 4 to be elected out of 10 people. This is the way we have to select. 10 plus 45 plus 120 plus 210, 385 ways one voter can elect. So that is the number of ways in which one voter can vote is 385. The number of ways in which one voter can vote is 385. the set S equals to 1, 2, 3, 4, 5, 6, so on 12. Is to be partitioned. This set should be partitioned into 3 sets A, B and C of equal size. Means 4, 4, 4. 4, 4, 4. 4 plus 4, 8. 8 plus 4, 12. So we can easily understand the set S up to 12 is to be partitioned into 3 sets A, B and C of equal size. Thus, A union B union C equal to S. Yes only. A intersection B equals to B intersection C equal to C intersection A equals to null set. Null set only. Because 1, 2, 3, 4 if you take, 5, 6, 7, 8 you take, null set only, no intersection. Like that. The number of ways to partition S is very easy. 12C4 first group, first division. What is that? First partition. How many people will be left? 8 people. 8C4 second partition. How many people left? 4 people. 4C4 1 only. So 12 factorial by 4 factorial whole cube. See how fundamentally we have learned assuming the balls to be identical except for difference in colors, the number of ways in which 1 or more balls can be selected from 10 white, 9 green and 7 black balls is very easy because already I have told 10 white balls, no selection, 10 selection. 9 plus 1, 7 plus 1. No selection is one way, we have to subtract. Then only 1 or more balls. 3, 8, 7, 9. 8, 7, 9. Same phenomena I have discussed before this. This was given in JEE. Okay. Next you see one formula, we have learned it, I told it. NCR minus 1 plus NCR equals to N plus 1 CR. Remember this formula, I have already told. You see here, suppose 8 C 6 plus 8 C 7. See, this is 6. This is one more, no, 7. 8, 8. And then what is the answer? If 8, 8 is there, 6, 7 is there, 8, 8 is there, you add 8 plus 1. C. R. What is the highest? 7. So what is this? 9 C 7. Like this. This you have to remember. On the basis of this application of the formula only, the question once it was given. You see, NCR plus 1 plus NCR minus 1 plus 2 into NCR. It is NCR plus 1, NCR minus 1 plus 2 into NCR can be NCR plus NCR. Now, NCR plus 1, these two, NCR minus 1 plus NCR, according to formula, what is that? N plus 1 CR. Formula I told just now only, plus NCR. Now, N plus 1 CR, you keep like this. N plus 1 CR, you keep like this. And this and this you take. What you are getting? N plus 1 CR plus 1. For this and this, you can write this one. For this and this, you can write this one according to formula. N plus 1 CR plus 1. Plus already middle one, I write here N plus 1 CR. So again according to formula, N plus 1, N plus 1, N plus 2, 1 we are adding, no? N plus 2 C, the larger one, R plus 1, N plus 2 CR plus 1, N plus 2, CR plus 1. So this is only on the basis of this formula, NCR minus 1 plus NCR equals to N plus 1 CR. The number of integers greater than 6,000 that can be formed using the digits 3, 5, 6, 7, 8 without repetition. Without repetition. 3, 5, 6, 7, 8. The number of integers greater than 6,000. Case 1. When number is of 4 digit, 6,000 means 4 digit. 4 digit number can start from 6, 7, 8. Because greater than 6,000, no. 6 you can write here, or else 7 you can write here, or else 8 you can write here. Then only it will be more than greater than 6,000 will be coming. So how many ways? 1, 2, 3. 3 ways. Next. Here 6, 7, 8 is over. Any number. You write 6 or 7 or 8. Then how many numbers left? 4 numbers left. 6 or 7 or 8 if you take out, how many numbers left? 4 numbers left. 4 ways this box. If you keep 4 ways this box with one number, 3 numbers will be left. 3 digits will be left. So 3 ways. So this is 3 ways, 1 number deduct and 2 ways. 2 numbers will be left. No, 2 ways. 2 ways means 2 digits will be left. So either 1 digit or another digit, 2 ways. This is thus the total number of digit, total number of 4 digit number which is greater than 6,000 is 3 into 4 into 3 into 2, 72. Next, case 2. When number is a 5 digit, because greater than 6,000 means that is 6,000 4 digit number, 5 digit number also will be more, no, will be greater, no. How many digits we are given? We are given 5 digits. We are given 5 digits. 1, 2, 3, 4, 5 digits. Therefore, any 5 digit number is no doubt greater than 6,000. Any 5-digit number just greater than 4-digit number. Okay. So when number is 5-digit, total number of 5-digit number greater than 6,000 is 5-digit number 5 factorial 120. Any number we can keep. Any number. Any way we can arrange. So 5 factorial. Because 5 numbers are there. Greater than 6,000. These are 4 digits. These are 5 digits. 5 factorial ways these 5 digits can be arranged. All the numbers will be definitely greater than 6,000. That is 5 factorial 120. Total number of integers 72 plus 120, 192. We are going to stop here because time is so much. Please go through this. Thank you.